This is video 23, and this is talking about applications of exponential growth and decay. Remember, our basic exponential formula is y equals a times b to the x. Okay, a is your y-intercept or initial amount. B is your common ratio. Okay, so first let's talk about our growth formula. Okay, and this is for percent growth. Okay, both of these are dealing with percentages. Okay, so we're going to start with f of x equals a times 1 plus 1, just plus r to the power of x. Okay, so it looks a little bit more difficult, but it kind of has this, just all the same parts of our basic formula. Okay, f of x is our total, our a is our initial amount, our r is our rate, it's our percent as a decimal. Remember, always make sure to put that as a decimal. And x is our time. Okay, so let's go ahead and look at a couple. We've got 2 examples. So the current population of Town Hillville is 5,000. If it grows at an annual rate of 15%, what will the estimated population be in 5 years? Okay, well, let's figure it out. What is our initial amount? 5,000. Next part of formula, 1 plus. Okay, because we are growing. The percent as a decimal would be 0.15, and we're looking at time of 5 years. Okay, and this is going to equal our total. So let's type this into our calculator. Okay, 5,000 times 1 plus 0.15 to the power of 5. Okay, and we get this big number with a decimal. Now remember, this is a population. Okay, we can't have 0.7 of a person. Let's just go ahead and round up. All right, so it's approximately, that's what that squiggly equal sign means, approximately 10,057 for our population. All right, Salvi raises geckos and sells them for a profit. If he currently has 24 and knows that they will grow at a 23% rate, how many will he have in 8 years? Okay, so we're starting off with 24 geckos. They're growing at a rate of 23%, so 0.23, and we're looking at 8 years. Okay, if we type that into our calculator, we should get around 126 geckos, which personally is a ton of geckos. All right, so that is our growth formula. Now, our decay formula is so similar, okay? Okay, only thing different here, oops, let's make this an X. Only thing different here is now we have a subtraction sign. Okay, f of x still means our total. A is our initial amount. R is our percent as a decimal. Remember, it's our rate. And x is our time. All right, so the population of parakeets in a region is decreasing by 8% each year. If the initial population was 12,500, what will the population be in 10 years? All right, So our starting amount of parakeets, oh, too many zeros, times, or decreasing, so it's subtraction. Now our rate, remember, move your decimal point over twice, so it's going to be 0.08. Okay, chances are if you make a mistake on something like this, it'd be that you put 0.8. That'd be 80%. And we're looking at 10 years. Okay, so all you got to do is type this into your calculator. That's going to be approximately 5,430 parakeets. So in 10 years, the population almost is halved. All right, last problem for our decay. Maria just bought a minivan for her family for $25,000, and she estimates that it depreciates at 12.5% per year. What will the minivan be worth in 6 years? Okay, so a car like a minivan probably won't get more expensive like a Camaro or a Mustang. Okay, it's just a regular old minivan. So it's not going to get more valuable with time. It'll get less valuable. So depreciate is another word for decreasing, which that means we're going to use our decay formula. So the minivan starts off being $25,000. It decreases 12.5%, so we're going to put 0.125, and we're looking at 6 years. Okay, now this is money, so make sure you put that dollar sign. It'd probably be worth about $11,298. And here we can put cents in because with money we have cents. Okay, so with problems like these, write out your formula and then use your calculator. Okay, and just plug it in all in one go. All right, so that's growth and decay. We've got one little extra section, which is compound interest. Okay, and this is mostly when you deal with money. Okay, so our letters change a little bit, but pretty much means the same thing. Okay, if you put money in a bank, you'd want it to be compound interest because you'll get more money than just regular plain interest. Okay, so let's figure out what all these letters mean. A is our total. P is our initial amount, but when you talk about money, it's your principal. Okay. R is our rate as a decimal. N is the number of times compounded in a year. And we're going to talk about that here in a second. And T is time. Okay, so with this, number of times compounded in a year, that means the number of times they're going to re-add interest. Okay, so if something was compounded quarterly, that would be 4 times a year. If it was monthly, that'd be 12 times a year. Daily, 365. Okay, weekly, that's another one. 52. Okay, and this can go on and on and on. But the more times it's compounded in a year, the more money you're going to have. Okay? So, Kim's grandparents invested $3,000 when she was born at 3.25% compounded quarterly. So, how much money will she have when she is 18? Okay? So, let's take our principal, $3,000. 1 plus our rate is 0.0325. Now, the number of times it's compounded per year. It's compounded quarterly, so that's 4 times a year. And that's to the power of 4 times 18, because 4 times when she's 18 years old. All right, and then just go ahead and type all this in your calculator in one go, and we should get $5,372.26. So basically they got $2,000 for free just by keeping it in the bank. Okay, so that's why investing your money is really important. Okay, last problem of this video. We have $15,000 invested at 4% or 4.75% compounded monthly. How much will we have after 7 years? So let's look at our initial amount. It's compounded at 4.75%, and we're compounding monthly. There's 12 months, and we're looking at that for 7 years. Okay, so if we type that all into our calculator, we should get $20,903.02. Okay, so that's almost $6,000 of free money that we could get if we were able to invest it at that rate. Okay, so those are our 3 formulas for our applications and our word problems. The biggest thing is that you are only going to use this compound interest formula if you see the word compounded in the problem. If you do not see the word compounded, you're just going to use your regular growth and decay formulas.